Hello, nice demo here for you to do with pressure in gases and liquids really. So here's what I'm showing you here. This is a Bic lid. I've sealed the top off with a bit of blue tack. So I'm going to trap a little air bubble in there, and not surprisingly, look, it floats. So if I squeeze that, it pops out and a bit of water comes out. Nothing particularly special happens. Look at that. Okay, there it is floating. So I'm going to put the lid on. Let's see. Got some arrows here. Why is this floating? Well, fundamentally, why is this floating? It's because this force here, which is called upthrust, is matched by the weight down. So if the upthrust matches the weight, then we're going to get this to float. But what happens if I do this? I'm going to squeeze this now and see if we can spot what happens. It goes down. Now, why is it going down? Well, it's not because the weight changes. What happens when it goes down is the upthrust changes. The upthrust up changes because it's going down. Well, why would that happen? Well, it really comes to something to actually the structure of the particles and how they're different in liquids and gases. We've recently done that as the pressure of the liquid, the density increases. And that's because of the extra weight pushing down. The extra weight at the top pushes down more down here, causing a higher pressure. It's not exactly the same in gases, because gases have this unusual, a different structure to liquids in that there is a large space between them. So when we apply pressure to gases, they actually become more dense, they take up less space, and so that bubble that we can't see inside the pen lid gets smaller. If it gets smaller, that means we've got less buoyancy and less upthrust. A liquid, however, has already got a very close structure. Liquids in some ways are more similar, in this respect, they're more similar to solids. Liquids are really considered incompressible. The particles are already so closely packed together that even though pressure's going up, their actual density is not changing. And it's actually the relative density that's causing this upthrust. As soon as I let go, the force has become balanced and the upthrust will equal the weight. But as soon as I start squeezing, upthrust reduces, and if I had another hand, I'd stick it on to show the weight remaining constant, but I don't. Or maybe I can do that. Let's see. There we go. There's the weight now. Let's have another go. Boom. There we go. That's what we're looking at now. Thank you.